Okay, so at this point, we're ready to talk about sign number representation, and we're going to use two's complement for the negative numbers. Okay, so this is a table that goes through this process that we've already talked about. So if I use just a 3-bit case, okay, if it's a positive 3, it just encodes to just regular binary 3. Anytime there's a positive number, you don't have to do the two's complement. That's the whole point. Okay, and so the way that this is structured, there will always be a 0 in the most significant bit position for positive numbers. Okay, for 3 bits, the range is +3 to -4. From this table, you can see for 4 bits, the range is +7 to -8. For 5 bits, it's +15 down to -16. Okay, so I think it's useful to actually write these down. Okay, so cover up the answers, write down the tables. And so I think one way to do that is, let's say, for example, -2. Okay, 2 is zeros. Let's do 4 bits. 2 is 0, 0, 1, 0. Flip all the bits, you get 1, 1, 0, 1. Add 1, and you'd end up with 1, 1, 1, 0. So it's not hard to do that calculation. -2 converts to this number. Then you do -3 and you get this, and you see this pattern, and it's not too hard to just write down all the answers that show up in a 4-bit two's complement representation. Okay, and so then you start to notice a pattern. Hey, this goes between 3 and -4. This is 7 to -8. And so the general range for n bits is 2 to the n minus 1 to 2 to the n minus 1 minus 1. Okay, so if I took n equal 3 here and plug that in, I would get -4 to +3. Okay, notice also that for all the negative numbers, you have a 1 in that most significant bit position. Okay, so the MSB is known as the sign bit, and that's how you tell. If you have a sign number, you can look at that number. If it's got a leading 0, you know it's positive. If it's got a leading 1, you know it's negative. Okay, and the last thing I want to talk about in this video is talking about sign extension. Okay, so notice that if I had 3 bits, let's take +3. All right, if I have 3 bits, and then I extended the representation to 4 bits. Okay, notice the only thing that happens is the sign 0 gets replicated. Okay, so I had 0, 1, 1. I just add another 0 at the end because that's what happens with a positive number. Okay, and then if I added yet another bit, I just sign extend it with the sign bit. Since it's a positive number, the sign bit's a 0. It extends over this way. Okay, let's talk about -4. Okay, so -4, the sign bit is a 1. All right, if I converted this to 4-bit two's complement, the number becomes 1101. And you notice what I did to get this number from this number, I just extended a 1 into the MSB position. And the same thing happens over in 5 bits. So sign extension is where you take the sign and you extend out to the number of bits that you're using to represent that that negative or that sign number. Okay, so that's a thing that I want you to play around with. I think it's useful to write this table down and sort of talk yourself through what it's representing.